Welcome, everybody. We're going to be working on our Chapter 7 exercises tonight. We are working in Unit 7, covering Chapter 7. This unit does span 2 chapters. You'll notice there's 2 different significant topics. One is dealing with strings, and this is something we actually have been working with all along, but there's a lot about strings that we kind of don't really formally talk about in Java, and strings really are not what you think they are. They're actually characters, and they're a collection of characters, really, which is why it's kind of tied with these 2 chapters. So strings, in essence, are really an array of characters. We haven't learned what arrays are yet, but we'll talk about that. Strings also, because they are a class, they're not really a primitive data type in Java, like an integer is, for example, or a character, or a double or something like that. So that gives them kind of a special category, but also gives them a lot of capabilities in the process. So like there's a bunch of methods that go with strings, and we use them for lots and lots of different things. So some of this might feel a little rudimentary as we're doing it, but that's okay. It's just kind of the pattern of how this book is put together. I'm going to be looking at the exercises here. I think the first one we have to do is exercise 2. And this one is called Baby Name Comparison. And it says, write an application that prompts the user for 3 first names and concatenates them in every possible 2-name combination so that the new parents can easily compare them to find the most pleasing baby name. Right? Save the file as Baby Name Comparison. Now, this is actually going to go very, very fast. So I hope you guys are ready to code. I am launching Eclipse here, putting stuff in my spring 2024 folder, which is the semester we're in here. I'll give Eclipse a chance to launch. With any luck, we'll get through this and maybe even start touching upon Chapter 8 tonight. That's kind of my hope. You do see that I have all my old stuff is open from last week, so I'm going to go ahead and close everything. I'm going to come over here to the side panel. I'm going to create a new Java project. And we'll just call this Chapter 7, since that is what we're working on. I'll hit the Finish button, and we are up and running here. Now we're going to create a new class file inside the source folder, and we're going to call this Baby Name Comparison. Right? This will be an executing program, so we will do a public static void main. No package declaration is typical. And here is our blank program. All right. First thing we have to do is we have to think about what the problem is. And the problem is to have the user basically enter 3 names they might consider, and then we'll grab them all and then rearrange them all. All right. So some of this is, like I said, very rudimentary, and it's kind of a combination of kind of reinforcing some skills, and then also maybe finding new efficiencies, and then thinking about the combinations we need to solve the problem. First thing I'm going to do is, since we're going to capture 3 names from the keyboard, I'm going to declare 3 string variables. Let's call it name 1, name 2, and name 3. You see, I'm declaring them all in one line. I'm not assigning anything to them yet. That can be problematic if you leave it like that, of course. You don't want to occupy memory that you don't need. We will be interfacing with our users, so we are putting our scanner in. I'm letting it underline red, and I'm doing control space to add the import of the Java util scanner. Right. As is typical, I'm going to call our scanner input, for lack of a better idea at the moment, and we will instantiate a new scanner object, which utilizes the system in libraries. So grab stuff from the keyboard. All right, so there's kind of our, our stuff being set up. Now let's start prompting our user for input. So we're just going to do a few system.out print lines. And let's see, how are we going to phrase this? How about we say enter baby name 1, except the type to 2. Baby name 1. Right, so there's our first prompt. Let's get a semicolon in there at the end. Then we're going to capture that and store it in the first name, name 1. And that will be equal to our input dot next line. Which is highlighted, so I'm just pressing enter. You can imagine that this is going to be a repeating process here. So here we go with the next one and the next one. Then I'm just going to update the numbers. Okay. You see how simple this is. Now, the whole concept of working with strings is kind of fascinating, because when you start to think about a string, I mean, we kind of use it as though it's a data type, like we say like integer or whatever. But the fact that it starts with a capital letter is indicative in Java that we're dealing either with an object or a class, right? And just to kind of give you an example, when I pull in the scanner, notice the scanner is a capital S, and its whole library starts with a capital letter. Even the system library starts with a capital letter, so it tells you it's a class file or an object. And objects travel with data. They also have methods built in and constructors, and usually all sorts of like crazy little features, that allow you to manipulate them on a higher level than you could with primitive data types without writing your own functions. So these are 3 prompts. We're capturing 3 names from the user. And now our task is really actually pretty simple. We just need to output what we got in every possible 2-name combination, right? Well, this is going to be system.out. And we're going to do .println. And then we're going to do this over and over again. So what I'm going to tell you is I'm going to be strategic here and just type one of these and then figure out how many combinations I need. So this is kind of an interesting little problem. If I'm provided 3 individual things and I want to take those 3 things and combine them in pairs in every possible way. And so in other words, one possibility might be that, I get name 1 and name 2, and I can output those as name 1 and then name 2, or name 2 and then name 1. So like if I had John and Joseph, for example, I could name the kid John Joseph, or I could name him Joseph John, if you kind of catch my drift here. Now, if you know anything about mathematics and you start to look at the possibilities that are generated by using how many 2-item combinations can I have with 3 items? Well, the answer is 6. I think they call it a permutation, and there's formulas for it and everything. So basically, what I'm saying is I'm going to use 6 system out print lines here. All right, so there's 2, 3, 4, 5, and 6. Now, all I need to do inside here is come up with the right syntax to combine them. And this is going to be very simple. So I'm going to say name 1, right? I'm going to concatenate to it a space in between. And then we'll concatenate, well, logically, name 2 would be a good choice, right? And since these are all going to be variants of this, I'm going to be clever. And of course, copy paste all of them in, and then just tweak the numbers, right? So it's just a matter of getting all the right combinations. With name 1 going first, name 2 can be second, or name 3 can be second. If I start with the second name on both of these, then the second name can be the first one and the third one. You see kind of the pattern here, right? That's kind of the solution here. And then on this one, we would start with 3 on both of those, and then we would, I'm just kind of keeping our logical pattern. I guess this could have stayed a 2. That a 1, doesn't really matter. All right. The other thing that we kind of want to get in the habit of, and I know I don't really enforce this a lot in this class, but whenever you open up a scanner where you can grab input from the keyboard, it's a good idea to add this in. And I don't know if you guys notice, like when you're using the scanner, you typically get this little yellow thing here and it says restart leak. Input is never closed, right? So let's close it. Right? That's kind of the point of that. It's just considered good etiquette in programming. And what that means is like you're grabbing stuff from the keyboard, release that resource so somebody else can grab input from the keyboard, right? There's no reason why you should be hogging this. As long as this program is running, it's trying to hog the keyboard is really what it is. By issuing the close command, we're releasing it and something else can use it, right? One could argue that the close command should be right after the last prompt. Sure, but this happens so fast it's almost irrelevant at this point. All right, this is all of the code here. Let's run this and see what happens. All right, so here comes the run. Expand the console here. So enter baby name 1, and we'll say John. And I see a mistake I've made already, so and I'm going to tweak that. Then I also mentioned before Joseph, and then let's throw in a Mark. All right, so we can do John Joseph, John Mark, Joseph John, Joseph Mark, Mark Joseph, Mark John. There you go. Those are all the combination. The thing that I noticed that I did make a mistake on is really these should not be print lines. These really should be prints so that we stay on the same line as we're doing the prompt. I think it's a lot clearer for the user. So just to kind of save that and run it again, just to show you. And this time, of course, we can run it with female names. So we can call it, I don't know, Mary, Sarah, and Linda. There's all the combinations that you can get out of that. So that's the program, folks. Nothing too difficult. Just kind of reinforcing those like basic string skills. Kind of interesting, a couple little takeaways from here is being able to collectively declare the variables. Remember to do print if you're want the cursor to stay on the same line. The next line method here absorbs what's typed and the pressing of enter. And then we've done this stuff plenty where we've just output text. And this is just kind of a matter of figuring out all the different permutations that are possible. Also, the other takeaway is to remember to close your inputs, and this is really common. So like if we were reading and writing to a file, for example, we'd also want to release the file. If you guys have had the Python class, you know what I'm talking about, because that's what we do in that class too. All right, I'm assuming this worked okay for you guys. This one's not really too difficult. So unless you squawk, I'm moving on to the next exercise, and the next exercise is exercise 3, and this one's got 2 parts to it. And it says create a program that contains a string that holds your favorite movie quote. Display the total number of spaces contained in the string. Save the file as count movie spaces. All right, sounds pretty simple. The next one is write an application that counts the total number of spaces contained in a movie quote entered by the user. So all that's going to change is we're going to prompt the user to enter something, right? With the first one, we're going to hard code it. All right, so I'm going to go ahead here and start building. One thing you might want to think about is what your favorite movie quote is. And we want something more than like, 2 words or something. We want like a few lines, basically, is what we're looking at. All right, let's go ahead and create a new class file on this. And we are going to call this count spaces. Now, this is kind of an interesting little problem, because the reason we count spaces is this one method towards getting to the point where you're learning how to split words apart and extract them for what they are. So if you can count the number of spaces in a string, it's usually relates to very closely to how many words there are in a string, right? Because usually there's a word, a space, a word, a space, a word, a space, etc. And if you do a sentence correctly, you start with a word and end with a word, which means there's one less space in between than there are total number of words. So the total number of spaces typically leads to being one less than the total number of words, typically, right? Excluding special characters and stuff. All right, since we're hard coding the first one, we're gonna once again create a string, and we need something to call this, and you know what I'm gonna, I'm not thinking of anything clever. Last time I called my string a string, but you know what? This is really a movie quote, right? So let's just call it movie quote. And what I'd like to do is I'd like to just hard code one in here. Now I have one that I used last time, and as I look at it, I'm not really even sure where the heck it came from. So you know what? I'm gonna defer to the global brain trust here, and I'm gonna just come up with favorite movie quotes. Not quotes, but quotes. All right. All right. I'll go with the Forrest Gump one. Although I like the Planet of the Apes. You know what? Let's go with the Planet of the Apes. It doesn't get much better than that. I don't know if you guys have ever seen that movie. Not the new ones, but this one from 1968. It's actually a very good movie, and beautifully overacted, by the way, by Charles Heston. All right. So here's my quote: "Get your stinking paws off me, you damn dirty ape!" Right. Um, and let's not even worry about attributing it to Charles Heston and like who said it, okay, or what movie it comes from. Hopefully, people know. And so here is thing. And if you're constrained on space, and I bring this up because like if you're going off the edge of the screen, you don't have word wrap turned on, and you still want to maintain the integrity of the string, you could always split it. And I'm not going to do this actually, but you could split the string in two, preserve the space, right? And then move the other portion down to the next line. And that's a perfectly valid layout too. So I'm actually going to leave it like this just to show you that this, even with the concatenation symbol, this is still one entire string, right? Remember, right? If you're forgetting, the plus sign in Java is the symbol we use within a string to join strings together. We're not like doing math here. We're connecting the two together, and they're connected in order. Okay. All right. So if we're gonna like process this now, um, what I'm trying to remember what the directive was. Um, display the total number of spaces contained in the string. That's kind of our objective. All right, well, we're going to count them, right? So why don't we go ahead and create an integer, and let's just call it num spaces, and that's the variable we're going to use to count them. We'll set it to 0 to start with, just to have a value in there. And I don't know if they're asking us. Okay, they're not asking us this, but I noticed that last time I did a couple of things, and I'm trying to think of why I did it, and now it's kind of resonating with me. If we're going to go ahead and look at a string to figure out all the spaces within it, and I'm going to kind of defer now back to this concept, and we've done this a bunch of times now, where if a string is really just a collection of individual characters, and the very first character is a capital G, that sits in the 0 position, E sits at the 1 position, 2, 3, 4, right? And so we actually have to traverse the string one character at a time and test each character to see if that character is a space. If it's a space, we'll count it. If it's not, we won't, right? Now, if we're going to do that process, given the fact that a string is really an array of characters, then we need to traverse that array or collection of characters, if you will, systematically, one at a time. We know that the strings have index values. How do we know that? Because it's in our readings, basically. But if you think about and I don't know if I've ever done this with you guys, but if you like um, bring up a spreadsheet, and I am bringing up my email here really quick, which I hate to do when I'm recording a video, but I'm just using it to get to my Google Drive, basically. And I'm going to create a new um, spreadsheet. And I probably have done this with you guys already, so I apologize if it's very redundant. But when we um, think about concocting, you know, some string, I'll call it, right? And then a string is composed of a whole bunch of letters. And I'm going to just kind of make these smaller, and you'll see kind of my strategy here. I'm going to merge this cell, and then we're going to put in 0, 1, 2, 3. Oops, I want to go here. 3, 4, 5, and 6, right? I think I've done this with you guys before, and if not, you probably have seen this in the Python class. And then what I'm going to do is I'm going to put borders around all this stuff here so we can more clearly see it. And I'm also going to center everything. I'm just trying to create like a visual representation of the kind of data structure that we're really working with here to help maybe have it resonate in your brain a little bit more. So if I have, you know, let's say some words, right? A word would be broken down into individual letters. For example, maybe like this. And I'm just saying the dog. So this is a string. Now, the way that this structure works, and this is why the chapter 7 is bundled in with chapter 8, because chapter 8 is about arrays, which is basically the structure we're looking at. But a string is a type of array. You know, each portion of the string is a separate character. Every character that's put into the string has an index value given its relative position. In this case, 3 is blank. That's a space, right? And that's the kind of thing we're looking for here. To traverse the structure, now that we know how to do loops, right, we can do that looping to traverse the structure because it's ordered. It has an order to it. And because it has an order, all I have to basically do is figure out, well, I can start at position 0, and then I can keep going until I get to the end. Well, how do we know we got to the end? All right, well, I would check to see what the length of the string is. In this case, even though it goes from 0 to 6, the result of the length would be 7, right? And so I would traverse it from 0 up until 6, right? Really up until 7, because it's 7 values. But remember, computers always start counting with 0, so that's always a factor, right? But this is the kind of structure we're working with. So I think that this is helpful to look at, right? So because I need to figure out the length of the string, I don't know how long of a string, like if I give this to a user to enter a movie code, I don't know how long it's going to be. It could be 5 characters, or it could, it could be like hasta la vista, baby, or it could be like a speech, So I'm going to set up another integer, which I'm going to call string length. We don't know what it is yet, but we're going to take the string that we have above, the movie quote, and we're going to run what they call the length function. This is just kind of a first example of one of the special types of functions that's automatically part of a string, right? So all strings have this function available. Like it's like, how long is your paper? If your paper is like one long string of text, well, this will tell us how long it is, right? In this case, we'll get a length of the string above. Now, it would be all the characters, including punctuation and spaces, right? So that'll run automatically, store a value over here in string length. All right, now that helps us to build our loop. So I'm going to do a for loop on this one. So I'm going to say for, we'll set up our loop control variable here for I equal to 0. Why? Because we want to start at 0. And then as long as I is less than string length, right? In this case, it'd be 7. Going back to that spreadsheet, we would never reach it because we're doing less than. If it was less than or equal to, this wouldn't work. If it was less than or equal to, actually, I could switch it to string length -1. but no need to, because this will be 7. We'll only go up to position 6. Every time we go through the loop, we will increment our loop control variable, and then we'll set up some curly brackets here. All right. Now, knowing that strings are a collection of characters, we are going to evaluate one character at a time. So inside here, I'm going to set up a character called CH, right? That will basically reach into the movie quote and extract the character at which position? Position I, the one that we're currently on. It's going to start at 0 and then count up to 6 before it ends, right? Every time through, it will capture the character and store it. Then we'll run an if statement to see if the character is equivalent to a blank space. Notice I used single quotes here. I could use double quotes too, actually. But I think, and no, that's not true. I think characters in Java prefer to use single quotes. That's kind of a convention here. So if the character equals a space, then I'm simply going to take the number of spaces, the variable we created above, and I'm just going to do a plus plus, right? It adds 1 to it. All right, you could also do num spaces plus equals 1, same difference, right? But in Java, the plus plus is really kind of the preferred approach. All right, that's going to loop through automatically, count the number of spaces, and then we're ready for output already. And so down here, outside of the for loop, I'm just going to do a system.out.println, and then we're going to say number of spaces is space, and we'll come outside the quotes, and then we'll just display the number of spaces. We'll see if it's correct. Now we can, if the quote is short enough, we can just look at it and count them and verify this. So what I'm expecting when I run this is 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 spaces is what I'm hoping for. All right, let's save this. And here comes the run. And number of spaces is 9. You want to test it again? Well, you just use a different quote, right? All right, so that's part 3A, count spaces. There is a part B on this one, and as is, I think, pretty typical on these, what they're having us do is just basically prompt the user. So the user will enter the quote at the prompt manually or paste it, whatever. So we're going to call this program count movie spaces 2. So let's go back over to Eclipse and let's create a new class file. And we'll call it count spaces 2, public static void main. Let's get that built. Since the programs are very, very similar, there's no reason to reinvent the wheel on this. So we're just going to grab everything, basically, well, not everything, but all the stuff inside the main method, and then we'll tweak it, to make it appropriate for what we're doing. So here comes the paste. I'm also going to do a little bit of cleanup here because that sure didn't paste very cleanly. I think that looks pretty good there. All right, so we're not going to use this approach here where we have it hard-coded. However, let's go ahead and actually, why don't we just set this to a blank string? So we'll set up a movie quote. We'll still call it movie quote. I'll initialize it to a blank value so the user can have somewhere to put it. We will need our scanner. Control space to add the library. We'll call it input, and then we'll do that standard process of creating a new scanner. System in. Okay. Now we will prompt. Okay, so let's think about this here. Do we still need to count the number of spaces and the length of the string? Yeah, we sure do. let's go ahead and do our prompt though. I'm going to do it down here actually. So I'm going to say system out dot print singular. And what should we say? How about something like this? Enter an inspirational movie quote. So that's the prompt. Now we're going to absorb carriage returning and store it. We're going to store it into the string variable we created called movie quote. So we're going to take the input and then run the next line method to grab it, absorb the key press of enter. All right. Another thing that happens too, and we haven't really done a lot of this, but when you guys get into the Java 2 class, we tend to do it a whole lot more. But so when people are at the keyboard, and I'm just going to kind of give you an idea here, but I'm going to do it in the form of a comment, right? So this is a comment mark. But normally when people type, they type a word, they press space, type a word, space, type a word, space, type a word, space, etc. And often when they're done typing something at the screen, they often hit space. They don't even think about it, right? Now, if you think about the issue we had before, if I'm counting the spaces to determine the number of words and have an algorithm built around it, I don't want to like put in extra spaces because it would throw off my count, right? So I really don't need this extra space. So they actually have a method that they've got built for string. And this is kind of interesting because, okay, so I see one problem here right away. I'm asking this to store the length of the string before the movie quote is even entered. So right now, what is this value going to be here? 0. This isn't a good spot for it, is what I'm telling you. So that variable actually has to be placed here, right? I don't want to determine the length of the movie quote before it's entered. Makes no sense, right? So let's bring this up a little bit then. Right. The other thing that commonly happens too is if we're going to process the string, it might also make sense, and I'm going to show you this, but I'm not actually going to use it, to maybe take that string, and actually maybe the way to do it is like this. We can take the movie quote, maybe we will do it. You know what? I think I might just leave it in. And what I want to do is take the movie quote and I want to trim away the extra spaces that a user might put in either at the beginning or the end. And there's a method called trim that does that. And there it is, right? And trim basically looks at what we call leading spaces and trailing spaces before the string starts and after the string ends. Common, especially at the end, for users to enter the superfluous space. So the trim function would get rid of that. And you know what? I'm going to leave it, all right? And then I will intentionally put stuff in to test it. All right. Do I need to change my loop? All right, so we should talk about that. Is that loop set up in a way that I could just use it as is and it will work? Okay, the answer is yes, it absolutely will work like this. So the string length or how long we run is dynamic. We've trimmed away the space at the end. And we know it works because it worked correctly before. And then will this output correctly? It should. All right, so let's go ahead and run this at this point. So I'm going to hit that run button. It'll prompt me to save. And I'm going to keep it short to start with on purpose. So I'm not really sure what phrase I should use here, but I'm going to type in, okay, how about hasta la vista, baby. Watch what I'm going to do here. Extra space at the end. Okay. So how many spaces do I have then? Right now I have 1, 2, 3, and 4 at the end. The trim command should remove the one at the end, so it should come back with the answer of 3. And it says string index out of range. So what is happening here? Why is this breaking? Because this is really a good question. Um, is there a problem with how we're capturing it? I don't think so. Where is my error occurring? It is giving me a line number. Okay, so the line number is right here, line 16, and it says string index out of range. That means it's my index values aren't working correctly. So I think, I'll tell you what, I'm going to remove the trim command to see if that might be breaking it. Because we didn't have that before, and it seemed to work okay. So let's save it, and let's try running it one more time. All right, enter an inspirational movie quote. I'm going to type something different this time. Hey, whatever, this is cool. And let's see if it works. It says number of spaces 4. 1, 2, 3, 4. All right, let's try that again. But this time, let's say this is so darn cool. Extra space at the end. And it says 5. So the trim command's not working. Let's see if we remove this, if it'll work. All right. So here comes the run. Okay, whatever. Okay, it seemed to work. I'm not sure why it didn't work the first time. I think that was really weird. I don't remember typing anything weird. Right. Now I'm going to run it again, and I'll say, I can't think of anything good. To infinity and beyond, right? Extra space at the end. So you got 1, 2, 3, 4 spaces, but it should bring it down. So it doesn't like the trim command. So I must be using it incorrectly. Is really what it is. Now, here's kind of like one thing I will tell you, and this is actually kind of intentional on my part to kind of lead you down here, this path. And what you're seeing here is I'm hovering over the trim method, right? And it shows you down below basically a snippet of what we call the Java docs, right? So this is kind of interesting when you work with a good IDE for Java. It has access to the Java doc libraries, which is all the documentation. And just by simply hovering over a method that's part of the standard library, it'll pull its definition up. And you know what? It shows you how it works. And this is just the top part of the document, by the way. You'll notice in the bottom right corner of that yellow box, it says press F2 for focus. So I'm going to press F2, except my keyboard is flipped. So I have to do function F2. And then it gives me the whole screen. And then I can expand that and read. Or I can actually come down here and click Open Attached Java Doc in a browser. And I prefer actually to do it this way for a lot of reasons, because it's easier to read mostly. But it finds the command, right? And what's more interesting about this, it also shows you all the other, so this is attached to the string class. This shows all the things that are available as methods that I can use on top of strings, right? So let's read what the instruction or the definition says here. I'm zooming in just a click. It says trim. They show you what it should look like, right? Returns a string whose value is this string with any leading and trailing white space removed, right? And that's what I was hoping to do, but it didn't work. If the string object represents an empty character sequence, or the first and last characters of the sequence represented have codes greater than whatever, these are the space character, the reference to the string object is returned. Okay. So in other words, if you put in like a weird character in there that goes beyond the space code, it will, so, okay, so to just kind of explain how this works, a string is an object in memory. This will return a reference to the spot in memory as opposed to the string itself. Otherwise, if there's no character with a code greater in the string object representing an empty string is returned. Otherwise, blah, 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 blah. So it tells you, really how it works, right? And so, okay, so it says This method may be used to trim white space as defined above from the beginning and end of a string, returns a string whose value is the string with any leading and trailing white space removed, or this string if it has no leading or trailing wire space. So how does it operate? Well, it's part of the string library, right? So it should be working in our program. I'm not sure why it's not quite working here, but it says string index is out of range. So I will be really frank. I don't know why it's doing that, but it doesn't like this, right? And then it takes us to line 16. But what's interesting about it, this is really more about the Java docs, by the way, because sometimes you're like, hey, I wish I knew a way to take my string and do something with it. But if you hover over any string method, like this is another string method here. Once again, if I do F2, bring up the Java doc on it, and I can read it. And you notice that these are basically web pages, but they work inside this product. It shows how it works, basically. And it says returns the length of this string. The length is equal to the number of Unicode units in the string specified by length and interface character sequence, returns the length, blah, 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 blah. Right? Maybe it's a little too technical in its wording, but you know what? If you're looking at all these different capabilities that are built into strings, here's a kind of a list, you guys, right? And it actually gets a little bit mind-boggling how much stuff is actually available, right? So that's really kind of the Java doxing. I know in chapter 1 they talked about it, and it was really easy to ignore. What I'm going to do here is I am going to comment that out and just I'm not going to use it. Let's now run it and let's put in something more meaningful. Okay, let's run it. See if it's right. Number of spaces is 8. I got 1, 2, 3, 4, 5, 6, 7, 8. Looks good. All right, so this is count spaces 2. All right, you guys are okay so far, I assume? I assume. All right, let's move on to the next exercise. Forget which one it is, so let's take a look. This is exercise number 6. Exercise number 6 reads as follows. Write an application that accepts 3 strings from the user and displays one of 2 messages depending on whether the user entered strings in alphabetical order without regard to case. Save the file as alphabetized. Okay, so we're going to prompt the user 3 times, right? Displays one of the 2 messages depending. All right, so this should actually be pretty easy. All right, let's start building here. So I'm going to come back over to Eclipse one more time. I'm going to right click, create a new class file. We're going to call this alphabetize. Hopefully you spelled it right. All right, not too late now, right? No, you could still change it. Okay, let's go ahead and set up our string variables. Now you can do this a couple of different ways, right? Some programmers might do it like this, kind of like I did the first time. I might go string 1, string 2, string 3, right? Without assigning values at this point. Or actually, I could even assign values. So I could do stuff like, like a blank string if you wanted. Functionally, it's still kind of the same. So I'm not going to use that approach, though. I'm just kind of showing you it can be done. That's one method, but I'm going to comment it. I think what a lot of programmers tend to do is they tend to declare the variables on the fly as they need them rather than think about it in advance, create them all, and then use them, right? Because sometimes you have extras or not enough or whatever. We are adding the scanner. I better do the library thing. So control space and then equals new scanner, right? You see how like routine this stuff becomes after a while. And that's kind of the point, is you're comfortable with it. And then you can move on to like much higher level stuff. right? We're gonna prompt our user. So system.out.println, and actually we're prompting, so we're just gonna do a print so it's on the same line. And then we're gonna say enter a string. Right? We're gonna capture the input. This is where I'm declaring my variable now. So I'm gonna do string. I'll say, well, let's do string 1. And then we're just going to grab the input and do a next line and a semicolon. Repeating process, right? We do this 3 times, right? 2 and 3. We'll update the names of our variables. So they're all unique. So we'll do string 1, 2, string 3. The prompts look the same. I might say that it might be helpful to show them that it's changed a little bit. Enter another string, and then maybe enter yet another string, right? So the prompt changes a little bit so they know they're, doing something, right? That it's not stuck. All right, now we need to do the logic. The logic is kind of interesting because when we do comparisons of strings, I want you to think about this really carefully. Like, okay, how is it that I can tell if this stuff is sorted or not? Yeah, this is kind of an interesting thought. Here's what I'm going to do is I'm going to take us to the ASCII character. I'll just type ASCII chart, right? And what I'm trying to point out here is that whenever we're working with stuff that's on a keyboard, this looks good enough, right? So this is kind of a classic computer kind of science thing to do, is to look at all the character codes that are generated. And so really what happens at a keyboard, when I press a key on the keyboard, it generates a byte of data, which is 8 individual bits of electronic pulses, positive or negative pulses that represent ones or zeros. And those 8 possible values in a binary number system can be translated up to 256 characters in a base 10 number system. So you'll notice here that the first column of this table goes from 0 all the way up to 127. And if you look at the extension, it goes up to 255. Keeping in mind, computers start counting at 0. So it's 256 possible values that are available with a bit, or excuse me, a byte, which is 8 bits, right? 8 binary characters. So really what we're saying is that when you're pressing stuff on the keyboard, and some stuff you don't actually know how to press, but notice what the control characters are. So like if I press control at, that's equal to null, which is 0. I never knew that before. But line feeds, bells, escape, and they all have codes, right? Numeric codes that go with them. And none of that makes sense for alphabetizing. But when you finally get to the letters start at position 65, the 66th character of the ASCII chart. Capital letters go first, and they're in sequential order. So if I was to test to see if A comes before B, what we're really testing is, does the character code for A come before B, right? It's not, we know how to alphabetize letters. Computers don't. Computers only know how to do it based on its numeric value that's next to it. And so it makes sense that the alphabet's in order and the numbers go up as you go up the alphabet. Interestingly, when you are sorting stuff, does a capital A come before a lowercase a? That's a kind of weird thought, right? On a computer, it does, because 65 comes before 97. You see that on the chart, right? And so this creates a little bit of a conundrum, because when you're alphabetizing, who's to say that somebody didn't hold down caps lock or mistakenly hit shift or use the first letter capital when they shouldn't have, that kind of thing. So often when you are alphabetizing, what you do is you convert things either all to lowercase or all to uppercase, and then compare to see what order and what's alphabetical, right? Because then you're comparing apples to apples as opposed to, well, capital A or lowercase a, right? And you could write code to accommodate for that, but it's easier to convert it all to one case or the other and then do the comparison. So I think that's important to know. And maybe I've talked to you guys about this here in this class before, or maybe in a different class, that's possible too. So we need to write an if statement that's going to accommodate that. And a few different ways we can handle it. So I'm going to show you an approach that we don't necessarily have to use, but I could just take all of the strings. So I could say string 1 equals string 1, and then I can run the to lowercase function. So we'll take the string 1, turn it all to lowercase, then store it back in string 1. Right? I can do the same thing with string 2, string 3, string 4 if we had it, right? And then do my if statements. Okay, that's one approach, right? So I am going to comment that out. I'm not going to do it that way, because that's an extra step. And every time I'm doing something and then storing it again, it's chewing up memory space, right? And so I always kind of think about that when I'm writing code. Now, I could just write my if statement with the inclusion of the to lowercase method and then do my comparisons. Now, there's another little thing here. I'm going to start writing the if statement, and I'm going to show you what I'm going to do. I'm going to take the first string. I'm going to run the to lowercase method on it, right? So now it's converted to lowercase. But there's also another method called compare to, and I'm going to compare it to another string. Which one should I compare it to? How about string 2? And then we'll also make that one lowercase, so we're comparing apples to apples, basically, right? And here's what's kind of weird about this. When you run the lowercase to lowercase function, it generates a few different possible values. These are listed in your book, by the way, if you want a reference on it, or you can look at the Java docs. In fact, I will look at the Java docs, but basically what we're looking for is we're looking to see if the comparison results in a value that's less than or equal to 0. Okay. I'm going to pause right here because there's more to the statement and I don't want to get it too convoluted. Let's hover over compare to. Let's do the Java doc thing and pull it up in the browser here and do a little bit of reading on it, which I think is pertinent. So part of what I'm showing you here is that it's okay to look stuff up and try to figure out what's going on. The Java docs are a good starting place, but you might find that other websites are actually more helpful than the Java docs. Some of these are written so long ago that people didn't really know how to not speak computer geek speak when they do it. All right, so it says compares two strings lexicographically. It's based on the Unicode value, those numbers that we were just looking at. The character sequence is represented by its compared blah, 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 blah. The result is a negative integer, right? And you see that right here, if the string is preceding the other string. The result is a positive integer if it follows. The result is 0 if the strings are equal. Compare to returns 0 exactly when they're exactly the same. So basically, it's going to return a negative number if string 1. Okay, so let's go back to the code here. Negative number if string 1 comes before string 2, right? So in this case, this would apply, right? Or if they happen to be the same, so I type apple and apple, right? Then 0. So it either comes before or they're the same. If they come the same, they're alphabetized, right? It'll generate a positive number if string 1 comes after string 2, right? So And that's kind of how the method works, right? That's not all we need to test here, though, right? So if we're going to see if they're in order, we're going to take string 1 and see if it comes before string 2. And so we're doing our AND operator here. I am moving down to the next line to finish the statement, though, because there's not going to be enough room here. And if string 2 to lowercase compared to string 3 to lowercase, you guys see the pattern that I'm forming here. If that is also less than or equal to 0, or in other words, they're in order. So if string 1 comes before string 2 and string 2 becomes before string 3, or they happen to all be the same, we're going to call them alphabetized, right? So here comes the curly bracket now. And here we'll just do just a really simple message. Yeah, I'm pasting it, saying the strings are in alphabetical order. Pretty straight ahead. Now, a couple deep takeaways here on this, right? First, once again, we're using some unique string methods that apply to strings that allow us to use this technique. A very, very common technique is to, like, with the exception of maybe passwords, for example. But like if you put like a username in a system, usually you think about this, like you might have an email address. If you ever wonder why the email addresses you have are usually always lowercase, it's because that's how email systems store them. And so if somebody happens to type in capital letters when they're typing in their username for an email address, it's usually converted to lowercase for basis of comparison, or you convert it to uppercase, depending on how the system's put together. But I think 2 lowercase is more typical, but at least then you're comparing apples to apples. So it's another string method we're learning here, 2 lower, 2 upper. Then we also have this method compared to, which is another string method, which we were just reading up on and how it works and what the results it provides. So this returns a negative number, a 0, or a 1, depending on if things are ordered or not, or if they're the same. This concept where I take a string object, right? So like an object in a class, a string is an object, and I apply one method to it, and then right away I chain, and this is kind of like dot notation, if you will, another method to it, which also contains another method, but like string 1 dot to lowercase dot compared to, that's what we call chaining methods. And it's allowed in Java as long as it works out, right? In this case, it does work out. But there's so many of these types of like weird functions in the string libraries that we use for processing verbal information. Okay, so here's one example. If they're all in order as typed, then we're just going to say the strings are in alphabetical order. Right now, it's either they all are or they're not. There's no other checking we need to do here. If they weren't entered in alphabetical order and this statement doesn't ring true, then the only other option is that they're not in alphabetical order. You see? Right. All right. Let's save this. And then let's hit the run button. All right. So we're going to enter a string. And I'm going to make this really simple. So I'm going to type apple, banana, carrot, right? Fruits and vegetables. But notice I'm being strategic here, right? One starts with an A, one starts with a B, and one starts with a C. All right. The strings are in alphabetical order. Okay. Let's run it again. And this time, let's break it. Let's go apple, carrot, banana. Okay, so it's recognizing that they're not in order. Okay, let's test it further. What if I entered apple, carrot? What do you think the response is on this? Yeah, they are in alphabetical order. Apple and apple get converted to the same thing, right? And carrot follows. Yeah, that works. Or, and this is, the kind of stuff you really should be trying. If I did some capital letters in the middle, capital letter at the beginning, and then all lowercase. Are those the same? Yeah, they're still the same, right? I mean, because we're converting them and then comparing them. And if they're all the same, they're in alphabetical order, right? Let's say we can't have 3 carrots, right? So that's an example of this one working. Now I'm going to take just a really quick pause here in the recording. All right, so now we're going to go to the next part. So I'm going to go back to the instructions here for a moment. And I've got to find them first, I guess. Right here. So we're going to do the second part that accepts 3 strings and displays them in alphabetical order. Well, this is a lot different. We're not going to check to see if they're in order. We're going to, well, that's not true. We're going to check to see if they're in order. And if they are, we'll put them back up on the screen. But if they aren't, we're going to find a way to reorder them so that they are, right? And now this does get a little bit deep, and I'll be real frank. I'm not super particular about people getting this one exactly correct because the logic kind of goes down a rabbit hole a little bit. But I want to show it to you because I think it's pretty useful, generally speaking, because this is the kind of thing that happens. And then maybe when you guys, like next time you like use Chat GPT or something and ask it to like alphabetize something for you, you have a little more appreciation of the logic that's happening in the background that makes it happen, is not necessarily very streamlined. So let's go back and start by creating a new application here in Eclipse. So another new class file. All right, we're going to call this alphabetize2 with a public static void main. And I am going to begin by copying some stuff from the previous program. Makes sense too, because some of it should be the same. So there's the alphabetize. So what I am going to copy is all the prompts. So I'm just going to kind of copy all those. In fact, you know what? I'm going to copy all of this, and I'm going to show you kind of like my my thinking on this as I'm kind of working. First, I'm going to paste all this in. I'm going to do a couple of experiments before I write all the logic. This logic here will, for the most part, be completely replaced, right? All right, so the first thing I'm going to do is, instead of switching everything to lowercase here, right, which is fine, I could follow through on this approach, right, and convert them in advance. So let's try that technique just really quick. Like that. And if I remove that, these 2 lowercase things here, in principle, I should be able to remove all of them from here. And this is really what I want to test, right? So you see how much cleaner it makes this statement now, right? It's a lot easier to look at. Still doing the same thing. Let's run it. So this is basically the old program redone. All right, and let's see if like our thing works. Apple, banana. Okay, so it still works, right? This kind of shows you that that approach is going to work. So I'm going to stick with that approach. It makes sense to me to do this syntax here rather than have these like statements that are so ungodly long that they're almost impossible to kind of like read through. Now, we're still going to do some of the same comparisons, but instead of doing less than or equal to, we're going to start switching up some of the syntax. So here's what I'm going to do. I'm going to actually blow away most of this if statement here and kind of start over. We are going to take string 1 and compare it to string 2 still, right? And we're going to check to see if that's less than 0. Same criteria apply for compare to, by the way. So if that is true, right, and I'm going to go into curly brackets here, Then I'm going to run another if statement inside, and I'm going to say if string 2 compare to string 3, and like failing on my syntax here, you guys got to catch me on this. I get my parens in there. So if the result of that is also less than 0, then what we're going to do is we're just going to do a system out print line. This I'm copy pasting in. And normally if you do one statement inside an if statement, you don't need the curly brackets, but and I've had that come back to bite me so many times by ignoring to do that I'm not always comfortable not doing it. All right. And then I'm going to say here, else if, right, and then the new statement, string 3 compare to string 1, come out of the parens, if that's less than 0, in other words, it's ordered, then here's our output statement for that. Which will go here. And if that's not the case, then we're going to say else. And really, once again, like I said, I'm going to keep the curly brackets in here because I tend to get a little confused if I don't have them. Then this is the correct order. So really what we're doing is I'm making a test. So I'm saying if string 1 comes ahead of string 2, okay, let's just assume the first 2 are in order, basically, right? Then if the second string comes before, then the order is 1, 2, 3. Makes sense. Otherwise, if string 3 is before string 1, then I'm going to say is string 3, 1, 2. And then the last one I don't have to check, given the scenario. I just say 1, 3, 2. It has to be the order. Okay, so that ends this inner if, right? That's assuming the first 2 are in order, right? However, right? And so here's the however. Otherwise, we're going to say else if string 1 dot compare to string 3, right? So we go from 1 to 3. Those are in order. Then we will have this order. Now, I know that this is kind of a mind bender from a logic thing, so I don't feel bad, basically. I don't know how to say it. I don't feel bad if the students don't necessarily pick up on this immediately. That's absolutely fine. There's nothing wrong with you, basically. It's complicated to get the logic correct. So that's the first else if. And then inside this if statement, we're going to say else if again, and I'm not sure I'm liking this indenting here, so I'm going to go back to where it was. I think that's a little bit clearer. And in fact, you could even, like, honestly, you could indent it like this if this helps you see it. And I think actually that helps me see it. So here, let's just do that. Right. And this is like one of these like personal style things. It doesn't really matter how you arrange it. The other scenario, final scenario, is string 3 compare to string 2. And I have to think about this in my head for a second, even as I'm typing it, even though I have the solution sitting right there. Then we have another set of curly brackets, and that output would be this order. Else it automatically becomes this order. Now, the only way to know if this is correct, by the way, is to run it. Now, what a lot of people do, right, when they write an if statement like this, I'm going to show you the solution file I'm working from, which didn't have the 2 lowercase conversion. So here it is. So if you guys want to look at where it's coming from, notice that this doesn't have any curly brackets in it, because the way that Java operates, if you only have one statement and an if else, all this stuff is really considered one statement. You don't need the curly brackets at all, but I tend to get lost if I don't have them. Right. And I think that's really important. All right. So here's all the logic, you guys, basically. And let's go ahead and run this now. There's no other code we have to add in. If you guys are trying to get all the code all at once, here's the top. There's the bottom, right? If you're like screen capturing from your videos or whatever. But it's the running of it that's really important. So let's see if we can do this. So what it's going to do, remember, is no matter what I put in here, it's going to alphabetize it for me. It doesn't matter if I do like zebra, apple, monkey, for example. All right, let's try another one. I don't know, rabbit, television, carrot. And I'm just coming up with random words. So far, so good, though, right? It's gotten it all in the right order. What happens if I put stuff in alphabetically, and I could just type, there's an A word, there's a B word, that's not really a word, right? And then a C word that's not really a word. Does it work with things that are already in order? Oops. Okay, I failed. Let's try that again. Let's just do it with real words. It was probably punishment for not typing actual words. Back to our original stuff. It seems to work, right? So you could test every possible scenario that you could think of. And once again, not really a lot of code, but some kind of intense logic in a way, right? Because you have to really, really think about, all the different scenarios and how they break down, right? Pretty intense, really. If it helps you, and sometimes it helps me, like when I have like these else ifs that I do stuff like this with, indent wise, so I can see it, whatever. It doesn't really matter if else and if are on the same line if you're not picking up that clue, right? Because really, truly, it's an if, then another if, then an else, which has another if, and then an else, right? And then an else, which has an if, and an else, which has an if, and then another else. Right? All right, so that's the lay of the land for this one. Let's take a break. I'm going to save my work here. We're going to come back and we're going to start digging into the next chapter, so I get a head start on that. We'll do a 5-minute break here. I am going to actually stop this video here, and I'll start a fresh one when we get back.